In this lesson, we're going to look at situational problems that include angles. For the first part, we're just going to review some of the relationships between angles with parallel lines. So in this example, assume that the lines are parallel. So these two lines are parallel to each other, and determine the missing angle measures. Okay, so in this diagram here, we want to figure out what each angle or how large each angle is. So we know that there is an angle of 116 degrees. And I know that angle D is also going to be 116 degrees because they're vertically opposite angles. I also know that angle E is going to be 116 degrees because angle E and the initial 116 degrees are corresponding to each other. They're in the same position, just on two different lines. And then another vertically opposite angle to angle E is angle B. So angle B is also 116 degrees. So now we need to figure out the other types of angles, or the other sizes of the angles. So if I look at angle F, I know that the initial 116 degree angle and angle F are same side interior angles, and those angles add up to 180 degrees. So for angle F, if we do 180 minus 116, we will get 64 degrees. So angle F is 64 degrees. Then we can go back to vertically opposite angles. So angle A and angle F are vertically opposite, which makes them the same size. Angle A and angle C are corresponding angles. They're in the same position. So angle A and angle C are both on the top left-hand side of each of the lines. So angle C is 64 degrees. And then angle G is vertically opposite to angle C. So that is also 64 degrees. For the next part, we need to name the pair of angles. So what are each pair of angles called? So angle A and angle C. Angle A is here and angle C is here. Those are in the same position on two different lines. So on the top left-hand side of the line, so those are corresponding angles. If we have angle B and angle E, so here's angle B and here's angle E, those ones are vertically opposite. And angle B and C. So angle B and C are both interior angles and they're on the same side of the transversal. So they're same side interior angles. The next pair is angle F and angle C. So here's F and here's C. Again, they're both on the interior. They're both interior angles, but they're on opposite sides of the transversal. So these are alternate interior angles. Okay, we've got angle A and angle G are next. So A and G are both exterior angles and they're on opposite sides of the transversal. So they're alternate exterior angles. And then our last pair, angle E and angle G. So angle E and angle G are both exterior angles and they're on the same side of the transversal. So they're same side exterior angles. Okay, so now we're moving into some real life situations. So the first example says Danielle is a sheet metal worker. She specializes in sheet metal roofing that can be purchased in segments, snapped into place and secured with screws or nails. The diagram below shows two segments of sheet metal roofing. One angle is given. State the measures that angle 1, 2, and 3 must have. Explain why they must have those measures. Okay, so our first angle that's given to us is here, 76 degrees. And then we have angles 1, 2, and 3 that are over here. So now what we want to look at is two lines and a transversal. So we're going to start with our two lines. And we're going to assume that these are parallel lines because if they weren't parallel, then the roof would be crooked. So these are going to be parallel lines. And our transversal is going to be this middle line in here. So now we have our angle that we know of 76 degrees and our angle 1. So if we look at this, these are both interior angles and they're on the same side of the transversal. So I'm going to say our 76 degree angle and angle 1 are same side interior angles. So when we have same side interior angles, they need to add up to 180 degrees. So we're going to have 180 and we're going to take away 76. So angle 1 is going to equal 104 degrees. For our next angle, angle 2, if we continue working with the 76 degrees that we know, then 76 degrees and angle 2, again, are both interior angles, but this time they're on opposite sides of the transversal. So 76 degrees and angle 2 are alternate interior angles, and these are equal to each other. So we know that angle 2 is then going to be 76 degrees. Now for angle 3, we have to switch the lines that we're working with. So if we continue to work with this second line here and this one, and again, our transversal is still that same line, then angle 2 and angle 3 are in corresponding positions. So they're in the same position, just on two different lines. So angle 2 and angle 3 are corresponding angles. And corresponding angles have the same measurement. So angle 3 is going to be the same as angle 2, which is 76 degrees. In the next example, we have a trapezoid, PQRS, so just this large trapezoid here. We know that PS is parallel to QR. So these two, the top and bottom of the trapezoid, are parallel to each other. So we want to find the measures of angle 1 and angle 2. So for this, again, we want to look at our two parallel lines and our transversal. We're going to use this one here as our transversal. And we know that the same side interior angles add up to 180 degrees. So if we have our angle of 105, and then we have this large angle here, those have to add up to 180 degrees. So we don't have the entire angle right here because we're missing part of it. So we're going to start with 180. We're going to take away 105. And this bottom angle is going to be 75 degrees. So this large angle down here at the bottom is 75 degrees. So now to find angle 1, we know that this part has to be 75 degrees. Part of it is already 25 degrees. So we have to take our 75 degrees and subtract the 25 degrees. So angle 1 will be 50 degrees. So this diagram is not drawn to scale. It looks like the 25 degrees and the angle 1 are pretty close to each other, but just keep in mind that it's not drawn to scale, so trust your calculations. So angle 1 here is 50 degrees. So for angle 2, we are going to focus on this triangle that's at the bottom, and we know it's a right triangle. And we also know that one of the angles is 50 degrees. So if you remember the information about a triangle, all 3 angles need to add up to 180 degrees. So for angle 2, we're going to start with our 180. We're going to subtract the 90 degrees and subtract the 50 degrees. When we do that, we'll end up with an angle of 40 degrees. So angle 2 is 40 degrees. Okay, so again, this is not drawn to scale, so just make sure that you are happy with your calculations and you're not focusing on what the diagram looks like. So for our last example, the 2 vertical barrels in the diagram need to be moved to be parallel to each other. So by what angle must the second barrel be moved? So at the moment, they're not parallel to each other, or the 2 barrels are not parallel to each other. We want them to be parallel to each other. So if we use our 2 lines and our transversal, these 2 angles would be same side interior angles. And same side interior angles need to add up to 180 degrees. So we want to move barrel number 2, but we have to figure out how much we need to move it by. So we're going to start with our 180 degrees, and we're going to subtract the 106 degrees. That's going to be consistent. It's going to stay there. So when we do that, (180 minus 106) is 74 degrees. So that's what this angle has to be in order for them to be parallel. So to figure out how much we need to move this one by, we just need to subtract them. So 78 minus 74. So this angle, the barrel number 2, needs to be moved by a 4-degree angle in order for these 2 barrels to be parallel. So we want to move barrel 2 4 degrees.